Hey everybody, welcome to Houdini Hangout. We're here at the end of February. It's the 28th of February. And normally it'd be the last day, but we got a leap year this year, so we got an extra day in February. All that fun astronomy stuff. Hey Kenji, welcome. Yeah, another exciting adventure. Yes, hopefully. Um, yeah, welcome to the stream. Glad to have everybody here. Um, yeah, so if you were following any of the social stuff, I was planning on doing a stream on Monday, but just kind of got walloped with some cold stuff over the weekend, and so I was like, I really don't want my nasally voice to get even more nasally on here. So I decided, well, we'll pause that for Monday, but we are going to do that stream on. Hey Zach, how's it going, man? Welcome. We're going to have that stream on Friday because I didn't have anything going on Friday. So I figured, we'll do a Mops Monday, but on a Friday. So we'll switch it around. So that'll be a little different. If anybody is familiar with the Lego movie, I found a GIF. Well, it's technically not exactly what was said in the movie, but more or less that made me think of it. So it was I enjoyed that. Anyways, so that's I definitely think that's one of my favorite animated movies is the Lego movie. It's so good. Anyways, hey man, welcome. Vic, thank you for the suggestion for tonight. Sorry it took me an eternity to get to it, but hopefully it'll be enjoyable and we'll all learn something. Anyways, so that's so the plan for this evening is to do a little bit of some procedural animation using Vellum and using some forces and things like that in Vellum. That is at least the idea here, and I actually was sort of playing around with it because I was kind of like, I think I know how to do this, but I'm gonna just give it a little shot here and just see what I can come up with. But first, let's take a look at this here because I'm gonna make this a bit bigger. And let's see here. We'll just throw this up on the screen real quick here. Cool. So this is sort of what we're going to do here. Something like this, where we get a little. Oh yeah, Tom, you're right. Lego movies, great. Lego Batman. It's just the opening scenes from that are so good. But anyways, this is what we're going to try to sort of emulate here. We'll see sort of where we get with it. I have an interesting kind of take on it. I didn't want to just do like a 1-for-1 kind of thing. I figured doing something a little bit different and unique might be interesting. I think it should be fun at least to see kind of what we can get up to here. But it's basically what we're going to be doing is kind of setting up some procedural, workflows basically to allow us to control how this cloth is basically getting forced up in the air, right? And for how long and things like that. One thing I did add, I think I'm going to add to my setup is having a little bit of noise to the wind that's kind of pushing these up. So that's going to be something I'm going to try to do. We'll use a little bit of expressions to do that. Hopefully that'll make it a little easier to understand what's going on. We're not getting it in writing any custom solver type things. But just a little touch of Vex for some extra control. And yeah, should be good. So that is what we are planning to do here. But first, I want to make a little announcement here. Actually, where did that go? Okay, yeah, there we go. If anybody has seen, there's going to be a Ardini challenge starting on Friday. So that should be really fun. I have kind of a soft spot in my heart for ardini because it was a couple years ago that kind of got me to a point where I felt like I was able to start doing a stream like this. I actually started this stream at the tail end of the year that I did the entire ardini. I was like, I'm fast enough to do this. And then later that year, I was like, screw it. I'm going to start a stream. So, oh gosh, Tom, I'm not going to make a OpenCL custom solver. Anyways. Yeah, Mardini's awesome. Tom we had to inform Tom this year that since he's interning at Side Effects, he can't be a part of the winning of anything, but you can still have fun, make some stuff. Yeah, I can't win anything either, but I'll probably, I think I'll probably touch on some of this stuff throughout the month. I'm not sure how closely I'll follow it. If you haven't done this before, let me talk a little bit about what it is first. So you get these prompts every day, and they've kind of changed it a little bit over the years, right? So there's different ways that they were doing prompts. I think the year that I kind of followed it really closely, it was more like conceptual, like action words and things like that. So that's how it was working for when I was doing it. I'm just going to zoom in a little here in case you can't really read that very well. But this year they're going off of some nodes. So they had to nerf Tom. Yeah, Tom got nerfed. So just as a note for those of you who are used to the week starting on a Sunday, like in the US, that's pretty normal. This starts on Monday. So that's why I actually just looked at this and was like, why are there 3 days? I'm confused, but yep. Anyways, so each day, you're supposed to use one of these nodes, and it's pretty encouraged to use it as like kind of a core part of your workflow. Not just like, hey, I threw a spiral in the background or something like that, and there it is, cool. Like do something that is kind of using that on some decently. KG, yeah, that's it. The best laid plans, right? You want to plan for these things, and then you're like, well, actually, I got a little busy and couldn't do it. But hopefully, this will be some really interesting stuff for you to play around with. There's some really useful nodes in here that I think maybe if you haven't used before, this could be a really cool thing to mess around with. And the lab's lot subdivision SOP is actually one of the things we're going to use tonight. So that's kind of cool. I didn't actually use that. Oh, and that's pretty cool, Tom. Your lab's chaotic shape SOP is on here. So, hey, that's pretty cool. Tom helped out doing some HDA work for the labs team since he's in that branch of the company interning. So that's pretty cool. You have a ardini node, so you might not be able. So yeah, you can't. That doesn't even count. You made that. You can't even. You can't even look at that day. You got to just not even use Houdini on the 27th. That doesn't work. Anyways, so Ardini, it's great. Submit. There's a couple different ways you can win. You can do image animation. I always gave myself the insane task of doing animations, but do whatever fits you best. I think there's a couple different ways that you can win. Oh yeah, Grayscale Gorilla Plus is sponsoring this. Their assets, I am not getting paid to say this or anything like that. Their assets are really, like, the textures they've got are really cool. So if you have Grayscale Gorilla Plus, do it, use it. It's great. Or check it out if you don't have it, maybe. I don't know. Moeen's going to be, I think, one of the guides for this. He's going to kind of do a video a day. And so that should be pretty cool to watch. Moeen's awesome, super good teacher. Some little rules and things like that. I think you can get the best collection. So like the artist with the most points, you get points based on, how many days you enter. So you get a point for each day, depending on if you win, that type of thing. And then if you get all of them, if you submit all 31, you get the Iron Heart. So you get a little swag pack. And actually I have a Houdini hat from 2021. And so that was cool. Oh, cool. Look at that. So if you win, any of these best artworks, you get, wait, is that for a day? No. Okay. So the first place winners get swag, Iron Heart, best use of Grayscale Gorilla Plus. So if you have it, you can get a free extra year of it. That's kind of cool. So lots of, okay. T-shirts have been difficult to deliver in the right size to so many winners. Yep. There you go. So some details to follow on what's going to be the winners. But anyways, take a look at that. You can even win you can win a license of Houdini effects if you get the best artwork or animation or collection. So that's pretty cool. That's like a $6,000 prize. Anyways, Ardini, it's great. Check it out. It should be a lot of fun. But I guess that's about it for, all the chat to kind of start the stream off here. Just as I always say, kind of to start these off, if you guys have questions or comments or thoughts on how to do things better or smarter or more efficient or whatever, feel free to put those ideas and comments in the chat. If you have a question, always put those in the chat as well. There are no dumb questions here. I'm never gonna, I will promise to never be like, why are you asking that? That's a really dumb question. So yeah, if you have questions, somebody else probably does. So feel free to ask them. That's always a good. It's always a good thing to be able to kind of talk about these things and answer these questions live as we're kind of going through these setups and stuff like that. So always feel free to kind of. Are we alone in the universe? Wow, Mirko, that is. Well, I guess I did say there is no dumb question. And that certainly is not a dumb question. It's actually kind of on the other side of it where it's almost like how could I ever answer that? Personally, I don't know. I mean, I don't really like to try to guess at things like that. I think if we are alone in the universe, then that's kind of cool because it's like, just means that life is really precious and special and that we should really cherish the fact that, we got to exist in this one little corner of the universe where life happened. That seems pretty unlikely just mathematically, but you never know. And if we aren't alone in the universe, then probably, the likelihood of us ever meeting them is pretty low. The universe is a big place, but maybe we will. Anyways, there you go. There's my philosophy. I do really like astronomy and all of that kind of stuff. So that definitely is something I do think about a little bit, but anyways, let's get in and do some Houdini stuff and start rolling here. All right, so we've got the first thing. Well, actually, you know what? I just remembered there was another video that Vic actually submitted as well. Let me see if I can pull that up really quick, because that was another interesting one. We're going to do the one I showed already first, but the other one was kind of interesting too, and I didn't actually even realize that it was there until I looked a little closer and saw there was two links. This one was a Ben Watts bubblegum kind of effect. I don't know if we'll do this one. Oh, that's probably trippy seeing that with my head in front of it. I don't know if we'll see how far we get with the other one, and then we'll play around with this. This one's is a totally different technique. Just thinking about it, but I do have something I've been meaning to test because I learned something and was really frustrated that I was kind of dumb about something in Vellum before. But anyways, that's the other one that Vic had put in the suggestion. Ben Watts taught me shortest path. Yeah, okay, sure. Along geometry and stuff like that. Using the shortest edge paths and things like that. Sorry, just finishing my coffee before it gets cold. Anyways. Yeah, Ben Watts was really cool. I remember him talking at a SIGGRAPH and saying he was from this really remote place, and he is really awesome. He's cool. I remember him saying he is from a really remote part of Australia, and I was like, well, if he can do cool stuff in Houdini from a remote place in Australia, I can do that from a random place in upstate New York. So, anyways. Cool. All right, let's get into that first example and we'll go from there. Oh yeah, it's definitely decaf. It is definitely decaf. I am a little bit of a madman, but sometimes, you need a little coffee. I would literally drink coffee all the time. So it's just a problem, just a problem that I have to work on. It's a me problem. All right. So 24-228, let's call this, Vellum. What am I doing? What do we call this? Inflation. Sure. That's good. All right, let's do this and we'll we'll call this like sim grid inflation, something like that. And it's sim, so I always color them purple because I think I learned that from Applied Houdini and I'm still doing it. So some things you just never change. Interesting. Never noticed that before. All right, so let's grab a grid, use that as our starting point. And we're going to use the lot subdivision because I was playing around with that and it's really fun. So let's do that. It'll cause some more interesting elements to be made, I feel like. So let's first of all look at what this does and then we'll kind of go from there. So you can use some of this info for maybe if you get into Ardini into that last week. So this is lot subdivision. What it's going to do is it's going to subdivide each polygon into these random little like sections like this. And it's based on a noise, like noised positions like within each of these primitives in our grid. And it subdivides based on like kind of this, like where those points are scattered randomly, and then kind of makes a subdivided kind of grid from that. It's like yeah, okay, there you go. Yeah. They can do a much better job explaining the math behind it probably. But anyways, basically what it does is it allows us to make these like random little patterny things, and we can set the irregularity here so we can make it really regular here, right? So now we've just straight up subdivided. Or if we start doing this, it'll get more and more regular until we get these crazy kind of patterns out of it. And you can see that there's kind of a noise pattern happening here that's driving it. Some are really big and then there's small ones and things like that. So what I wanted to do with this was use it to make some interesting grid patterns, right? However, if you look at this, you're like, oh yeah, it's super random and stuff. But once you start changing the lot size, you realize that we still kind of have this underlying grid structure here, which I didn't want. So I'm just going to change this to be one big grid, right? So we've got one big grid. And now this becomes a bit easier to control kind of on a large scale, right? We can sort of control how we want this to go. And here we can kind of control how how these lots are built, like what their minimum size is basically. So we can do some of that. Also, I'm going to turn the irregularity down a bit. So let's maybe do this to like 0.5, and then we'll play around with this just a little bit here too. Yeah, maybe something like, I don't want to go too crazy with this. Oh, that's another thing you can do is the iterations, right? So we subdivide it each time. That's how this works, right? So it subdivides it once. You get a random point based on where that point falls. Then you subdivide it again and again and again. It keeps subdividing like that. So that's how this works. It's like a random there's like an algorithm. I can't think of the name of it, but anyways, that's what's used. Alyssa. Oh, cool. Nice. Very nice. Nice job, Alyssa. It's a cool node. Anyways, this is a cool one. And so you can kind of play around with this, make it however you want. We could maybe make it a little less irregular, something like, maybe like there. Maybe we'll do 0.4 on that. Kind of play around with this a little bit. I don't want there to be like super small divisions here. And also another thing too to think about, and the way I'm about to use this is each of these. Oh, okay. I was going to say, I thought it's been around longer than Alyssa was an intern, but that's interesting. That's good to know. So what I'm going to do is use each of these primitives, polygons, as kind of the kind of box that's going to go up and down. Now they're going to be different shapes and sizes and things like that. So hopefully that'll create a little bit more visual interest for us. But you can play around with these and kind of figure out, what you like best or whatever. You can kind of play around with a bunch of different parameters here. So I think we're going to start maybe, and that range looks good. We don't want them to be too small and have too many of them, because then we're making a bunch of little meshes and things like that are all going to be kind of brought in to Vellum, right? We're going to bring them in as separate pieces. So what I'll do first is kind of set the cloth up, make sure it's all working and pinned, and then we can start to actually set the animation up, because we want each of these to kind of animate with some forces in different times. So we'll look at how to do that, or at least a way that you can do that. There's hundreds of ways you could do it, I'm sure, but just the way that I kind of thought up to do this. So, so what I'm going to do is we want to remesh this, right? Because this isn't going to work for Vellum, right? So we need to remesh it in some reasonable way. I think, let me see here. So what I'm going to do is I'm going to do an enumerate here. And let's play around with a couple things here. So this, we'll add an index attribute here, and that's basically just going to give us an integer attribute on the primitives. Now there is a cluster attribute here, and you might say, well, why are these look exactly the same? And they can be the same. However, you can click cluster, and then that will, you can make a certain number of clusters and things like that. And then that can change, I believe. That's weird. They're all just -1 now. Why is it doing that? I don't know why that's at -1. That seems to be an error in the node. But anyways, I'm just doing this enumerate just to get a little bit of a cleaner index attribute that we can use and things like that. So so let's look at this. Actually, there's a remesh, but there's a fast remesh here, and I wonder if we can use this actually. I think it will work. Let's see here. Oh yes. Okay. So this is an interesting node, and it kind of does work. You can see it's nice and quick, right? Like we are able to remesh this in a really fast manner. And if we use the input attribute index, I think that'll make sure that it segments based on that. I think we can visualize the segments. Oh no, it's doing it all as one. Yeah, I think it actually needs to have like a UV attribute to make it work. Anyways, I tried playing around with this first, and I was like, this kind of isn't working exactly the way I wanted to. So instead, I went with a for each primitive. And so this way we can have it go through and work on each of our primitives individually. So here we can see, we can run the single pass, and we can see all the different, primitives that are getting, we're running through here. So that's good. So that's working kind of nicely. And then we could add just a regular remesh into here and start to play around with this. So you can see that we're getting, some remeshed geometry. And what we want to do with this is kind of get these a bit more regular. They're a bit kind of chaotic here, and like these are making some weird lines and stuff like that. And we really don't want that for Vellum. It's going to make kind of some messy simulation geometry, and it's going to kind of mess with our simulation. So what we can do is we can up, our iterations. We can also play around with our smoothing as well. It might be a combination of that, a little more smoothing, a couple more iterations just to kind of clean it up. In fact, the iterations seem to be doing the best job here. So we could just, do some of each of that, is a little bit of, like junk up there. I'm also going to reduce the target size of this just to give it a few more polygons. Let's see what we can get going here. Yeah, it's not bad. Not bad. Bring the target size down a little bit. Cool. I think that's probably good right in that range. Maybe we'll do like that. Just give ourselves a little bit of, I'm just going to close this up. So we need our, we need a decent little bit of geometry just to get some interesting results, right? We don't want it to be too big of polygons, or else we're not going to get anything interesting from it. Now, there's a couple of really nice things about running it through this way, right? Because in our example, we wanted the edges of each of those kind of individual, like kind of bulging sections to be kind of pinned in place, right? So we can do a couple nice things here. We can actually, once we remesh this, we could add a group. And we could go in, change this to points. I usually call this pins. And I'm going to disable this. We'll go down here to visualize this and then include by edges, and we'll say unshared edges. And now we can get pins from all these bordering regions here. And so when we do the for each and go through everything, each of these are going to be selected separately. And we can then visualize those individual things, and we can see there's the pins right there. All of those border points are going to be pinned in our simulation. So that's exactly what we want. We don't want those to be moving around or doing anything weird like that. The other thing we're going to want to do is we're going to want those index values to be brought up to the point level, right? Because we are going to, because all the forces in Vellum are done on the points, right? All the calculations really are done on the points. The primitives don't really have any bearing on the simulation itself, because it's all a point-based simulation. So we just need to bring the index value from our primitives and just promote that. So I think the safest way to do that is within here, and to do an attribute promote in here. And we can say from a primitive to a point, we're going to use index, and I'm not going to delete the original just so they both have indexes on them, just in case we need that for anything in the future. Just a little safer to do it that way. I'm also not using ID because that's something that that Vellum actually recognizes as an attribute and can really mess up the calculations. It can throw some errors and things like that. You don't want to have the same IDs on multiple points and things like that. Hey, Terry, welcome. Sorry, I didn't see that message from before. Welcome. Glad to have you on the stream. So at this point, we've got our pin group. We've got our indexes on all of our points, so we're going to use that in the future when we're applying our forces. But we know that we want to kind of identify the individual pieces and have. Hey, Guillermo, welcome. Hopefully, I said that right. Yeah, so we're kind of got our geometry working at a reasonable level here. So we're starting to get some, we've got our geometry at a decent level of like actual detail. We've got our points pinned. We got our pinpoint group set up, and we have our indexes on our points and our primitives, so we can kind of use that as needed. So, excuse me. So, let's now turn this into some Vellum geometry, and then we can start to actually play around with some simulation. So if we do Vellum Claw, Vellum configure cloth, wire that in, we're going to do a few different things. We're going to define the pieces from an attribute. In this case, we'll use our index attribute. So that'll just make sure that our pieces are well defined, based on, that they're not connecting across pieces or anything like that. Not to say that we really want to break them apart, but it'll be a little bit. See you, Tom. Thanks for hanging around for a little bit. You're leaving work so early, man. Jeez. So now we have these pieces kind of set up for our Vellum cloth. We're going to need to do some stuff with stiffness and some of those things, but we'll get to those in a little bit. So let's do a Vellum solver, add that in here, and just let that, what do you call it? Let that kind of calculate. Oh, that's interesting. Why is it black? Why is it black? That's really weird. Like a normal thing? What's going on there? Huh. That's weird. I don't know why that's black. Huh. Well, anyways. Get some sleep, Tom. Okay, so I'm just going to increase these a little bit, some sub-steps. It's not in black. Huh, that's weird. Yeah, it just must be a weird little visual glitch thing. Okay, so I'm just going to up the sub-steps and constraint iterations just a little bit, just to make sure that we're, resolving to a reasonable approximation of the simulation results. If you have those like totally down, like at 1 and 100, all the cloth can be really stretchy and not really, when you turn those up, then it like totally changed the behavior of how your cloth actually is. So it's better to kind of start with those on a little bit. Even if it does slow your simulation down a little bit, it'll give you much better, for me, it gives me a much better idea of what's actually happening. So let's set the pinpoints as well. We've got our pins. I think for this, I set the density just to be a little higher, just to give it a little bit more weight to it. And the stiffness, we're going to want to set that down a bit. So let's start like around 1,000, just to see where that kind of gets us. So let's do that. And we should start to get some bounciness here to our simulation, right? And let's just do a little flip book here of this and see what we got going on here. Then we can make some better decisions based on what we're doing here. So we've got, so these are all obviously falling down. They're bouncy and loose. Kind of depends on how far we want to go with that. Right now we're at 1,000. Usually my suggestion is to go through those factors of 10 first. So we've got those right now. Let's let's try this at 100 and see where that gets us. So it should give us quite a bit more stretchiness in our cloth. Should fall down quite a bit more. So it really depends on how stretchy you want this to be, right? And you can see that that's obviously quite a bit more relaxed. So it feels a little too stretchy to me in some ways. Like it just feels a little crazy. Maybe actually the thing that I'm really noticing is that it feels like it takes a long time for it to really settle down. So let's take a look at that actually, because what that is that's our damping ratio, right? So let's actually set this down a bit, and we should see that this will allow us to get these forces to kind of settle into a kind of a steady state, into kind of a rest position, because it's going to bleed out some of our velocities out of our simulation there and allow this to kind of come to a more chill state before we start adding in our forces and things like that. So if we look at this, we're going to see that that's going to kind of tone itself down a bit. Let's do a compare images here, and let's bring up our sequence list, and we can just A/B this against each other. And on the left is the original one. And you can see how much bouncier it is, like kind of continuously. And on the right, it's already really calmed down quite a bit. So, so that's something that can be done. So let's just kind of see where that leaves us. How far are these kind of tilting down? Yeah, that's working fine, I think. I think that'll be a good starting point for this. So I'm just going to turn that grid off just so we're not dealing with, two like grids kind of on top of each other competing visually. Okay, so we've got this part figured out, right? We've got our solver working. We've got the points pinned in place. You can obviously change your cloth settings to have more detail to them. You could make those triangles smaller, that type of stuff, like totally fine. It's really kind of up to you how you want to do something like this. And this, this is not just like a, hey, this is the only way you can do it, right? You could change the way the lots are subdivided. You could, in fact, if we change those right now, we're going to get much different results here, right? Because now this is a different grid and they're going to be bigger, right? And they're going to stretch a lot more, right? Because there's going to be, just like in real life, if there was a larger piece of cloth, you have points that are kind of secured on either side, it's going to sag quite a bit more in the middle. So, just something to keep in mind. That this is going to be a very different effect based on how you kind of start out these initial settings here. And what we could do as well, just to make this a little more interesting, we could turn on the index attribute, and we could see that and just visualize that to see sort of where we're going here with this. So if we come down here, we've got all of our colors. Yeah, it's so weird that that's still... That's really bizarre. I don't know what that's all about. something happening in here for sure. I don't know what the deal is. It's really odd. What color? Anyways, we'll just turn that off. I don't know why it's doing that, but that's fine. Yeah, okay. Well, anyways, it works. So we can just make this work like this. So now we can visualize these pieces. We're kind of back to where we were before. So we have pretty much everything, not everything done, but yeah, that's interesting. I think it's Razvan. Yeah, I don't know why that's not working. It's probably just a visual glitch. I'm really excited for, the viewport to be rewritten in Houdini in the next version. I know that was kind of hinted at coming, so that'll be a very exciting thing for that to become more and more finished, because I think the viewport is just needs a good kick in the pants. Anyways, so we've got this part of it, but we want to simulate these, or kind of make these blow upwards in some sort of random kind of fashion, right? So that's going to require us to apply forces based on each of these pieces, right? So the way that I think that this is easiest done is take each of these pieces and calculate like an activation point, right? Like an activation time or something that kind of fades in and out, maybe randomly across the grid. And then we apply that in the Vellum solver using a pop wind, with a couple little expressions in there that kind of help us just control where our attributes are going. You could do it a few different ways in the Vellum solver. You could do it a few different ways in SOPs here before we get into any solvers. But I think that this way is pretty easy to understand and hopefully will be pretty straightforward. So what I'm going to do is we're actually going to jump back up to here. And we can just add a null in here just so we know kind of what stage we're at here. So I'm going to call this, we'll say in maybe grid polys or something like that, just so we know what we're dealing with here. It's kind of in the middle, so I usually make it a yellow. And then I'm just going to type centroid. So we're going to extract the centroids from these. Didn't I turn on my little displayer thing? That was weird. Anyways, so we're going to extract the centroids of each of these primitives, right? We can do this a few different ways. So we're going to run this. We could run this over pieces, primitives, whatever. I'm just going to run it over pieces because we have attributes that we can use. We can use index, and I'm going to just change my visualizer here so we can see this a little better. We're going to say 8, geometry, point size is 8. And that way we've got a little bit better visibility. And maybe if I do my background to dark gray, that'll be a little easier to see. Yeah, I think that's easier to see. Okay, so now we have centroids for each of our primitives, right? So this is good. We have a point that we can manipulate to tell it when we want these different kind of cells, I guess you could say, in our like fabric cells, when we want them to activate and have forces applied to them. So what I'm going to do is I'm going to calculate, kind of a start frame for these across this grid of points here, this kind of random subdivision of points. So what I'm going to do is do an attribute adjust, add, attribute adjust, integer. I think this is a great way, if you're not super familiar with Vex and all that kind of thing, to just kind of start building attributes. So I like to show this a lot of times because a lot of people maybe don't even know about these. And so what I'm going to do is I'm going to use the bounding box and the range. So we're going to call this start frame, right? And we're going to say start frame from bbox. That's bbox is actually a expression function that you can use to kind of calculate stuff based on the bounding box of geometry coming in. So like as a detail kind of almost attribute, like detail level calculation across the whole geometry. So it's just kind of a little short thing, bbox, typing in there. Okay, so what we can do here is we can use the bounding box. We can look in X, Y, or Z. That's totally up to you how you want to do that. You can do it in, obviously Y would do nothing because they're all the same spot on Y, but I'll just do it in X, that's fine. And I can actually just compute the range here and say this will calculate the minimum and maximum across. And then we can control the minimum maximum values here, right? So since we're talking about frames, we want to figure out what the start and end frames that we want to kind of deal with are here. So let's take a look at this and see where we want to start the simulation. Let's see here. It's a little hard to see because of the way... Oh, there we go. I guess just in the smooth wire shaded it was doing that. That's really weird. Okay, this will be a little easier to see, hopefully. Hey, La Pampadura, welcome. Sorry, I got a little lingering cough still. Okay, so I would say around frame... could probably start it around frame 36. Probably be a good start frame for it. So we'll say minimum value is going to be 36. The maximum we could do is maybe 72. I don't know. We'll see how this goes. Oh yeah, I'm feeling fine. It's just a cold, but just not something I want to be putting my sneezing and nasally voice out on the internet. But I'm doing fine. Doing totally fine. So let's visualize this attribute. We can just use this little icon up here to click. And now we're actually visualizing our fall off attribute, or our start frame attribute. So you can see that this is going to be going across in the X axis. And you can see this kind of creating these lines of values based on, thanks, man. Based on where we are in the x-axis, right? So we're kind of going back and forth across it. So that's great. We could enable a post process here and set up, actually, sorry. No, it's up here, not the post process. Up here, we could obviously change, a few different things. We could say based on a ramp, based on the bounds, we could change this and kind of move them around how it's getting calculated. It's a little hard to visualize in some ways here because we're looking at kind of these rounded attributes based on where we are across, like in X and Y. And so it's kind of randomly assigning those based on, the X position. So not randomly, sorry. It's kind of linearly applying those across. So what we can also do here is just make sure we're saying set always, so we're not adding if there's an attribute that already exists. But you can see down here, we're getting a start frame attribute. If you can see that. Yeah, I think you can see that there. Okay, cool. So that's good. Let's also do another attribute adjust integer, and we'll use this to, we'll add to it, and we'll say, hey, Mr. J, welcome. Welcome to the stream. So here we're going to do we can add like a noise pattern to this, and I'm going to say middle and range length. So our middle value is going to be 0. And then we can add a range based on, basically plus or minus a certain number. And you can see here we have this variant. That's actually the value that we're going to add into this. So some of these are going to get 0, some are going to get -5 or 3 or 1 or whatever. So it's kind of plus or minus 5, right? That's the whole range length. So this is pretty useful if you want to have like plus or minus randomly applied to something like this. So instead of variant, we're going to say start frame, and now we're randomly applying that. If we go down here and visualize it, we can kind of see the difference here. We're adding in, you can see that this is now becoming a randomized kind of version of that. We're starting at the same spot, but we can control how close it is to the original and kind of add in some randomness. We can also add a noise pattern in. It'll be a little hard to see here because we've got sort of few points. The more points you have, the easier it would be to see this. What we could do, to visualize this just a little better here. I'm just going to do this real quick just to help you visualize it maybe a little easier. I'm just going to throw a scatter in here. I'm going to do like 2,000 points. We'll just wire that in there real quick. And what you'll be able to see pretty easily here, I think, is this really nice kind of organized setup here. And I'm going to do this actually at like 10,000 so we get really dense. And so there's our start frame, right? So you can see now we have bands of start frames, which you don't see in the other one. And then when we add in our randomness, it's kind of pushing that away, right? So we're pushing it kind of away from that based on some noise. We can change the noise patterns here to make them larger or smaller. So we could do something maybe like that, maybe like 2.5. We'll just kind of round it off. And maybe we'll do, cool. Yeah. Good. I was just trying to think of a way to kind of visualize it a little bit easier. Because this is what's happening here. It's really spread out. So if you check out Mr. J, if you, I think you can actually rewind. If you're on YouTube, you can just rewind it a little bit. You can see at the very beginning of the stream that there was a little video that we're doing where we're kind of having this like bouncing cloth, and so we're setting up some controls for that right now. So we've got our start frames here, and you might be thinking, okay, what the heck are we going to do with these start frames? Like, that's cool and everything. Oh, you have zero knowledge in Houdini. Okay, well, welcome. This might be a little bit outside of the absolute beginner level, but please enjoy. Yeah, that's an interesting thought too. Yeah, you could use a picture too to drive it. Well, that's interesting. Yeah, if you had like a black and white photo, you could certainly remap that image and do something like that. So that certainly would be doable. It'd be pretty interesting, actually. I hadn't really thought of that. But yeah, if you took a photo, it would actually activate based on the brightness values maybe of that photo or something like that. It could be really interesting. Okay, so we're going to use a node that you might not use too often, but it's called the attribute fade node. And so what we can do with this is some really neat things. So what I'm going to do is, first of all, I'm going to change the name of the attribute to, maybe we'll call it activation. That sounds interesting. So it's kind of like an activation float. So this is going to create a float attribute that's called activation. And we can have our fade start frame based on, let's see. Oh, that's fun. Got a little error there. I don't know what that's all about. I might have to, thought that was maybe my other computer when I was playing with that. So we're just going to say start frame here. Start frame. And let's visualize activation. There we go. So what you'll see now is a really interesting difference. You're going to see these kind of random points kind of flash across the screen. And you might think, oh, okay, it's interesting. Like, fine. That's fine. But what we can do is some interesting things with this start frame attribute, because right now it just looks like these flashing weird dots that are kind of moving across. But if we go over to this timings tab, we've got some really cool stuff here. So one thing I'm going to do is I'm going to change the frame fade hold frames to be, let's see, if we wanted to stay up for a half second, that would be 12 frames. So let's do that. We'll do 12 frame hold, and you're going to see this is going to change quite a bit now. And so purple is 0 and red is 1. So as this fades between purple and red, we're going to see this activation going on and off. In fact, let's change that. Let's change the ramp colors of this, because I think maybe white to red will be a little easier to visualize. So here you can see white would be 0, red's going to be 1, and everywhere in between is going to be fades, right? They're going to be float values in between. We also have fade in and out frames. So if we wanted this to really fade for a long time on the out, we can control that as well. So now you'll see that this has this really hard beginning edge, but it's going to fade out over time. So there's some really interesting things that can be done with this node. And really all we're setting up is start frames, right? Now, the other thing I was just thinking about as I was doing this was, what if you wanted multiple fades per point? And I'm not sure how you'd go about doing that, actually. I'm just really curious now if that's possible. Like I would almost think you would have like an array of start frames that you would create, like random start frames, but I'm not sure. It's very interesting to me now. I'm not sure if that would work or not. But anyways, we'll use this for right now, and we'll just maybe cap this at like 144, just so it's not too long. So that'll just be like one ramp through. And the really interesting thing here is that this is totally procedural. Like, we're not simulating anything. So in order to do this, to tweak this, we could just come in here and, yeah, we could certainly put an attribute fade in a loop or something like that for sure. You could do that. I was just thinking if you wanted it to be slightly random every time, you could do, like, there's probably some mechanism there that you could use. I'd have to think about it a little bit, but I was just was something that kind of came to my mind as we were kind of thinking about this. But so what we can do here is you can see is as we change this range length, we're going to get this, this offset is going to be a bit different. This is the noise, obviously, that we're adding in, right? And if we change our element size, that's going to change how like random this is going to be, like on a scale, like from kind of point to point, how random is it going to be? So this is kind of spreading it out more, like where the start frames are, and this is kind of changing the noise patterns and things like that. And also we could change these in real time, and they'll adjust. So this is totally procedural. There's nothing going on here that is that's simulated or has to be calculated, ahead of time, which is really, really helpful for doing this type of work, right? Where you don't have to you don't have to have a pre-simulation to fire this off. So what we get at the end here is we get this activation float attribute, right? And so you can see that this will go through here and it'll kind of work its way down and things like that. We've got our colors that are also activating from that. I'm going to take the fade out frames because it's actually better to just kind of have it either on or off. You could tweak that depending on how you want it to go. And you can also change these ramps as well. Those will certainly change the behavior. So, totally, up to you how you'd want to do it. But this one thing to keep in mind here now is we have an index attribute for these, right? Each of these has index attributes, and they perfectly correspond to the indexes of each of these groups of polygons and points. So if we look over here and we turn back on that index attribute and we jump over here, they should match up color-wise even, because we should have the same value. So this is bright green here, jump over here and it's bright green. So that means that we have matching attributes across them. Now it's not super easy to visualize there, but it's a way you can look at that and see it really quickly. You could turn on markers and things like that, but I'm not going to clutter the visual, of what we're looking at here. But so that's good. So we've got these two things that we can work together with, right? And that's the whole idea of Houdini, right? Is that you have attributes and points and primitive, point, vertex, detail attributes that you want to use to manipulate things happening in simulations. So that's what we can do now. So now let's merge these kind of two streams back together, but we're going to do it in the solver. So what I'm going to do here is say null, and we're going to say, we can call this maybe like force activate, something like that. We'll make that green because that's kind of the end of the chain. So we're going to use this as a reference within our solver. So let's go into the solver here and let's add a force. So we're going to use a pop wind. This should be pretty easy to use, pretty straightforward. Let's ignore the amplitude noise stuff for right now. We'll just leave that as is. And what we can do first is just do some straight up wind speed. So let's just do, 4 in the Y up axis because we want to push this upwards. So that's positive Y. So we're going to push these upwards, and let's take a look at what we got here. So we should have all of these now blowing up with the wind. And actually that's maybe a little too intense. Actually feels like it's pushing a little too much. It's really going to depend on the scale of your individual, grid and things like that. So, your results may vary. So let's do 3 and give that a shot, because I don't want it to deform to a crazy level, right? Yeah, that feels pretty good. That feels like that's right. It's not overly stretching. I mean, maybe we could do the middle ground and just say 3.5. So up here we have our wind velocity, wind speed, air resistance, things like that. Oh, actually, I usually like to turn the air resistance down a little bit just so it's not getting the full brunt of it. So actually that will probably be, I think I was using 4 in my little tests and things like that. So that probably explains why. And the reason I like to turn that that air resistance down is it feels like it allows it to be a bit more natural and not be locked into the forces that you're applying to it. It allows there to be a little bit of play in it. And it's not this is absolutely what this thing has to do. It's kind of okay, we can give it a little bit of flexibility and allow it to kind of move naturally. So that's great. We're getting what we wanted there. So let's now look at this and see sort of what it is that we need to do in here to make this work. So again, we're not going to worry about the noise or anything like that, but what we are going to do is use our Vex expressions. And this is basically just using Vex, but in kind of a little bit of a not a simpler way, but in a little bit of a contained way, because we can't write Vex attributes from here. We can't do anything that we're used to doing with Vex if you're familiar with it. All we can do is affect these parameters on this node, right? So we can affect all of these parameters here using some Vex. So what we're going to do is we're going to first pull in that data from that source that we made, right? That null. So let's go to our inputs. We're going to say input 2 is going to be from some SOP data, and let's pick that. So we're going to grab this here, and let's go up to force activate, and we're going to say accept. So now our input 2 is going to be connected to that null, right? That null path. So if we were to, for example, turn on our show for selected nodes, we'll see that there is now this kind of orangish, brownish kind of arrow that's showing that we have a connection here between our Vellum solver and our force activate here. There is also a connection between those. However, this is the one that we just created by adding in this input right here. And you can see that we have this little 1 right here, which is also telling us that we have that coming in. So if you're ever interested in that, you can always turn on your dependency links. Sometimes it can really muddy up your network, but it can be a really nice thing to do from time to time. And hopefully that just visualize it. No, it does not matter where the flag is inside of this solver. What I'm doing there is I noticed that this wasn't refreshing properly for some reason. And so sometimes just hitting this flag back and forth will like update it, but it's not. So I don't really know what's going on here. But anyways, I'm definitely having some weird visual bugs with this. I don't know what the deal is. But because there's a lot of other things happening inside of this Vellum solver, that flag does not matter because ultimately it comes down much later in that network. So you can just leave it at force or whatever. Those are just outputs. So this is it's just telling us when we're in here, like where the output should be. And you can see it does sometimes update. So that's why I'm clicking around there. But it shouldn't matter, but you can leave it at the bottom. That should be fine. Anyways. All right. So we've got that connection made, with our input here. So input 2 is going to a SOP. So let's write some Vex and just get that attribute in. So we know we have a float attribute coming in, right, that we need to look up. But first, we need to make the connection because we're going to be running this pop wind over every point. So we're running this over our points, right, because pop forces are point forces, and we're doing a point simulation in Vellum. So we're going to run over our point, and we need to connect what matching point is from the other one because there's something like, let's see how many points we have here. We have, let's see, we have 9,000. Well, I can just middle click here. We have 9,240 points in this grid when we've remeshed it. And over here, we only have 128. So we have to match up these 9,240 points to this 128. So we have to find their matching counterpart, right? Because each of these points corresponds. And if we look at this here, actually, I can control click this and it'll actually keep those points visualized too. So you can see each of those points corresponds to these grids, right? So we need to match all of these to this one central point for all of these. So like all of this grid here needs to connect and know that it's looking at the information from this one point. So, and the reason I'm doing that too is because it's way quicker to do all this processing over here. It's basically instant. So if you're trying to do that calculation across all of those points and then average them together or do something like that, there's just a lot of extra calculation that just kind of doesn't need to be executed, right? Just going to add time. So anyways, so we need to get that. We need to look that up. And there's a function called find attribute value. And what this allows us to do, I'm just going to hit F1 here. Oh, that's the wrong one. I was thinking I needed to hit function, but I don't. So what this is going to do is it's going to find a primitive point or vertex that has a certain attribute value. So here we can look at a certain geometry. We can look at the class. We know that we're looking up points. So we know that's the class. You can see here we write point. We need an attribute name for it. We know the attribute name is going to be, I think I have it called activate. And then what point what value do we want to find for that? Or no, I'm sorry. We want to find the index value. That's the attribute name we want to look for. And then what value are we using? So we're going to use the current points index value and look that up in this other geometry. So that's what we're doing here. So let's just type this in. We can keep this up just so we can see the code that we're trying to type here. I'm going to enlarge this a little bit just to make it a little easier to see, hopefully. So we're going to say, first of all, we want to make an int attribute, and we'll say match PT or something like that. So the matched point, right? So this is our matched point. It's going to run this for each point in our geometry, in our simulation geometry. So, all right, so we got to say what geometry we're looking at. So 0 would be this geometry. 1 would be the second input geometry here. So you can see the input. The first one is itself, basically. The second one is whatever you set there. So this is a little different than how wiring stuff works in SOPs, but it's kind of the same concept. So here we're going to say 1 because we're looking at the second input. It's computer world, so 0, 1, 2, 3, 4, etc. The attribute class is going to be point. The attribute name is going to be index. And the value is going to be I at index. So the reason I'm doing that is because I'm saying the current point's index value. So just, I'm going to minimize this real quick, and I'm going to open up the Vellum object, look at our geometry. So this is now our geometry spreadsheet kind of inside of DOPS, right? It changes a little bit. But if we look here and scroll over, we can see that we have indexes for each of these. So what I'm saying by saying I at index is looking for this value for every point. You can see as we scroll down here, that index is going to change, but change slowly, change in groups. So here's 88, but this is point 6,239. So, we have to kind of match that up to something on the other point. And it could be that we're looking for point 88. It might not be. So in that case, it's just better to just say, here's the value I'm looking for. Let's match those up together because we know that those values were sourced from the same spot. So if for some reason you resorted your geometry and all the primitive numbers are different, your index should stay the same. So it's kind of a way to kind of decouple which primitive you're looking for and which point and all that stuff. It just allows you to be a lot more explicit with what you're looking up. So there's that, and then the value. So that's the value we're using. And the last one is not necessary. Basically, this is just saying if multiple elements have the same value, it says which one to return. We aren't going to have multiple ones of the same value. It's just not going to happen. They are all unique. So we don't even need to worry about that. We're not going to have multiple returns on that. So like if you had multiple points that had the same index, which point do you want to get? That's kind of what you're saying, either point 0, 1, 2, 3, etc. Okay, so that's our first line. Cool. The next thing we're going to do is use that matched point and then look up our activation attribute. So this is going to be a float that we want to pull up because this is going to be that faded on attribute. We're going to say float. We can say this. Let's say we'll just call this activation. And we're going to say point because we know we're looking up a point value. We're going to be looking at geometry 1. We're going to be looking at activation. I believe that's the attribute we're looking at least. I will go back and double check, but I'm pretty sure that's right. And so for this one, for point, we're saying which geometry, what attribute, and then what point number. So the point number is going to be match PT because that's the one we just looked up. So now we have our activation, so that float value that we're going to multiply everything by to make this force happen, right? So from here, what we can do is we need to know what value we're going to, influence here. So what we can do is we can influence wind speed. And if we look here, there's a little thing that says parameter, and that's the name that we want to type in here. So what we're going to do is say wind speed, right? That's the wind speed is the name of that parameter. And we're going to say times equals, because we want to multiply this by activation. So that should now affect this wind speed. So we'll have this wind that will animate based on that. Now let me just go back and make sure that I was actually calling that activation. Yep, I did. Okay, just double checking. And let's run this simulation and see what happens. I am going to switch this visualizer over. So let's do this. Sorry. Let's right click on this. We'll say activation. And why is that showing that? That's weird. Let's just reset this again. What is going on here? Ba-ba-ba. Okay. There we go. And then I'm going to control click on this, and that should bring it up. And now we should have these. No, the null does not need to get wired in. The null is totally fine because we've connected these kind of virtually. There's kind of a virtual connection there. So that connection is made in this input right here. So this is kind of wiring it in. So saying input 2 is like putting it into the second input of this pop win node almost. That's a little bit different than how things work outside of that. So anyways, that should work. Oh, interesting. You can use the Vexpressions up here too. Didn't even notice that. Huh. Well, either way, this should work just fine. I did it down there before. So anyways, all right, so let's take a look at what happens here. We should be all set. So it's going to settle, and then we'll see these points will start to change color. And when they start to change color, because we're visualizing these over here, we'll see that the force is going to go up on them. Yes and no. So, no, it's fine. No, your English is fine, man. I don't know what language you speak, but it's better than my version of that would be. So, hey, your English is very good compared to my, whatever other language you might be speaking. So, anyways, no, that's an interesting question. So, yes, so first of all, we can see that this is working, so that's great. So what you might be thinking of is that why are we not wiring this into this second input here? Now, the reason for that is because we're doing things a little differently here, right? So this is a SOP-based. Here's a joke. I need perfect English for Houdini. Oh, man. Yeah, that's true. I mean, hey, at least Houdini is confusing even for English speakers. So, the reason that we're doing that here is I'm just going to show you what's going on here so you can maybe hopefully understand this a little better. This is totally unnecessary for anybody to do, but what I'm going to do is I'm just going to right click on this and say allow editing of contents. So now what we're going to do is instead of jumping into that, actually, let me match this current definition. When you see this little icon right here, what this means, and I actually just had a conversation with someone about this. I saw a conversation online about this and like, should that actually be like this? Should it be large? Because this is actually telling us that we're going to be going somewhere specific inside of this. Whenever you see that icon, it's basically saying we're about to jump inside to a very specific point of this HDA. Right? These are all Houdini digital assets, right? These are not like base level nodes. They're built of other nodes. And so like even this Vellum cloth here is an HDA, right? You can actually say anytime you see this allow editing of contents, you're looking at a node that is not the like end of the chain, right? There are some very base level nodes, right? Like an attribute promote, I can't change this. There's nothing inside of this. This is written like as a low level node, but Vellum cloth is an HDA. So what we're looking at here is actually a bunch of nodes inside of here. So when we normally click on this, we go into the dive target. That's what this is here. We've actually jumped into DOPS when we did this, which I don't really talk about very often, but we are in DOPS now. So that is kind of a big jump that we're making there. So when I go to allow editing of contents, that's now gone. We're now not going to hit that dive target. And when we click in here, we've now jumped inside of another network that you normally never see. So this is actually where those inputs, the input 1, input 3, and where's input 2? I don't see it. It's somewhere here. So those are here, 2, and that's colored purple. So that's where those 3 wires actually go, is to these different places. So this goes into this DOP network here. And then this inside is actually the simulation that's happening with Vellum Solver. And then our dive target is actually way up here, and this is where we just were. So we bypassed those 2 levels when we jumped in there. So that's why these don't correspond to anything inside of there. So if you said when you go inside of that that dive target in here, when you go into this, if you said on inputs, second context geometry, what that's actually saying is the second input to this DOP network, right? Which is the constraints, true, but it does not mean that in all cases. So we've kind of, because we're working at the SOP level, we've kind of decoupled those 2 things. So we are working with DOPs, but we're dealing with SOPs generally. So so that's why that's being done. And the other thing you just mentioned there, that you can do stuff with attributes for the cloth, right? Yeah, you can do that right before you put them in. I'm just going to reset this dive target back to normal. You can affect stuff on these wires, right? And do stuff with the constraints or do stuff with the actual points themselves. But those are kind of starting points for the simulation, and that doesn't automatically get brought in frame by frame. So updating things is actually better done in here, where we're working in the simulation world, where this is where the actual calculations are happening. So that's why we're seeing those things kind of updated, step by step. So yeah, I don't mean for that to be scary. It's not really necessary to know that, but just to know that there's other things happening, I think is important sometimes, because sometimes we forget that these little inputs and outputs don't directly correspond to that next thing that we jump into. So some interesting things there. And like, if you go into here, like, good night, that's crazy town. Don't even bother. There's just a lot of logic there that's being done. That's what all of this stuff is for. This is literally tools that the developers have built to make this work. So anyways, all that to say, that's what we're doing there with that connection. So we don't have to have that wired in, and it's actually easier to just have this sitting over here, which is time varying. You can see now we have a time here, so we know that this is a little clock there, so we know that this is going to update. And now we're pulling that in frame by frame, and that's showing up. And when you control click on this template flag, that actually shows it as like live geometry almost. Like, you can't select that geometry in here, right? Like, I couldn't go in and like select those points or anything like that, but it shows up almost as if it is selectable geometry. It's like a stronger template version. Like, if you normally just control click, you get these kind of grayed out versions, but if you just click on it, you get the grayed out versions. If you control click, now it's showing the attributes that are actually on it. So that's why I did it that way. So now we can actually see when these activate, and you'll see those colors change. So we're starting to get there, right? So that's good. So things are starting to work and do their thing. And you can see obviously that random control is going to the randomization from our attribute adjust integer there could be done to, vary this in all sorts of different ways. So what we could do here is we could just give it a little more offset here, something like this. And that might just give us just a little bit more randomization to this pattern as it goes across. Maybe we don't want them to stay up as high as long. You can change that in the attribute fade node. So it's kind of just knowing where to tweak those parameters. But this should now be a bit more random to where those points are actually starting. And yeah, that's just kind of a nice, simple way to be able to get this effect to start working. Jonah asked this, new in this channel, wanted to ask how important or necessary it is to learn coding for Vellum effects. Coding. Did I say code? I don't know what I said, but that sounded weird. Whatever came out of my mouth. So I think it really depends on what you want to do, right? So I'm doing something really specific here where I want forces to be applied to certain chunks of this fabric across time and doing some things like that. And so that can be a little trickier, right? To be able to make that work. Yeah, I think it's helpful. It's not totally necessary. Now, there's probably a way to do this differently. Let me think about if there is another way real quick. I think this is the fastest way, honestly, because we're literally writing a couple lines of code here and using one node, so that's really nice. I'm just trying to think if there's something else. Pop, anything else? I feel like there's definitely other ways you could do this. So what you could do, instead of using this pop wind, you could actually use like a VOP, right? You could use your node-based kind of coding and do that. So you could bring it in here, bring your attributes in, sort of similarly to how I did it before. You would set your inputs here. So we'd set input 2 to the same thing we set over here, right? So we'd set this SOP path over here and set this over here. So now our second input is connected to the same place. And if we go inside of here, we could write a similar, you could set up a similar node network that would bring in those values. It would do some lookups and things like that. But honestly, I think the simplicity of Vex it seems a lot scarier. I'm not a programmer. Like, I do not know programming well at all. But I know how to manipulate things in Houdini with programming, like programmatically. So what I would recommend is, like, if you are interested in like doing really, because like I think one of the folks just said so some people are saying yeah, I think a lot of people are saying that you could probably do this, but honestly, it becomes simpler when you know just a little bit of Vex. Like, and really what it is knowing like a couple things to search for, like here, find attribute, like just knowing the language of what it is you're looking up. Because like once I type in find here, right, I know, oh, okay, find attribute value. That sounds right. What about find attribute value count? Oh, interesting. They're like, just knowing some of these key words help you out. And then once you press this first little parentheses, it brings up this, so you could see like, oh, find, oh, that's finding a string value or something, So yeah, I did Joy of Vex, which is Matt Estella did a really cool walkthrough of kind of getting you introduced to Vex. You could watch, I did a video series then based off of his documentation. So you could watch that. That might give you a good introduction. I think there's also Moeen, who's doing the Ardini this year. He did a Vex Isn't Scary, I believe, which is a great one too. So there's different things out there to help you. But I would say don't be too scared by it, because it's knowing just a couple of simple things, like how, like what I'm doing here basically is just getting an integer value. And how do I get that integer value is by this function. And this function asks for a couple of parameters. They usually call them arguments that you enter. And once you know those arguments, it spits you back the number you want, right? So these functions are pretty easy to deal with a lot of times. Like this point function is used a ton, and right, yeah, you could do parameter interface and reference. Yeah, exactly. Sometimes VOPs can get real tricky to like make things work. Like doing looping and things like that can be a real nightmare in VOPs, I feel like, where it's pretty straightforward in Vex. But yeah, I would look into the joy of Vex. If you are interested in doing some really interesting simulation work, I think having even a slight knowledge of Vex is going to put you out so far ahead. To do basic cloth, no need. Totally no need. If you just want to play around with some cloth and make some just random, add some random noise to cloth and swirl it around and stuff like that, you can do that all without this code. This code is just making it so I can really specifically affect certain parts of this geometry with the forces. Just to show you, I can turn this off. Well, I'll save. If I wanted to do something maybe a little more interesting here, let's just say I didn't want to have any wind velocity, but I wanted to have some, I was just about to get some noise in here, but let's say I wanted to do this and just add some noise velocity. We now have some like wind noise that's kind of pushing this around, right? So we can get interesting effects to happen without having to, I'm just going to change a couple little parameters here in our noise, without having to do any coding, right? So let's just go back here and we'll just look at this and just see sort of what's going on here. I actually don't like the way that noise is looking. So let's do the swirl size a little bigger. No, Carlos, I think you're right. I mean, yeah, sometimes it is just like you're used to the words and things like that. Those are just math terms, really, I think. Integer and float and things like that. They're really just math terms. What really helped me, yeah. Somebody just said that. Toldja? Is that how you say that, your name? That's crazy if that's right. Somebody just wrote that and I'm like, what? That's the English way of writing that? That's cool. Either way, I'll say Toldja. If that's right, hopefully that's a reasonable way of saying your name. But yeah, you could certainly do something like that, based on, probably like element number or something like that. But yeah, there are other ways to drive these things. I'm just trying to do something not incredibly specific, but very specific and in an interesting. Tolya. Okay, cool. No, it's your name, man. Or whatever. Sorry, I said man is like a general thing. It's your name. I want to say it properly, so I don't know. Anyways, so hopefully that little tangent was helpful. I know that it can feel a little scary to see some of these things and go, what the heck is going on here? But anyways, okay, so let's put this back to where it was. That was at 4. And we're going to use our expressions again. Cool. So now the other thing that we can do here, is we can actually just add one more line and just say, the amplitude. So this is amp. That's the parameter. So we can say amp and then times equals, which means take that original value and multiply it by whatever I put next. And I'm just going to say multiply it by activation, which we set right here. So let's take a look at that and see. Okay, so the amplitude maybe we'll do at like 3, like a little less than the wind velocity. And let's see how this goes. So now we'll be back to the way this was working before. We'll have these kind of random and this should be a lot more interesting looking because we're going to get this little like ripply thing. It's not just going to go up and then down, we're going to get some little ripples in it, a little bit of force, kind of pushing it around, do something a little more interesting with it. So we'll let that, interesting. It's actually done by 120. I'm just going to change the length of this. And then we can just say to the end. I just hit the forward. There we go. And then honestly, I want those to stay up a little longer. They feel like they're a little too short. So let's do 18 frames. Excuse me. So again, I'm just going in and changing the timing of that fade. So these will stay on, like activated a little longer. So I think this will be a little bit more of an interesting thing. So we can actually give it a second of like, hey, it's inflated, and then it'll fall back down. And if you want it to fall maybe even faster, you know, right now there's like a 2-frame fade on that, but you could just have it be 0 frames and just turn it off instantly. And that's possible as well. So this is really cool, I think, because it's not derived of anything that is simulated, right? So it's completely procedural animation, right? We can just tweak this as we wish, basically, and change these parameters around and things like that. So I always like that kind of animation because I feel like you get a lot more control over it rather than animating something or doing something like that. Like, I feel like this is really controllable. So cool. So I think we're like pretty much there. I mean, as far as like the actual effect working, the last thing that we might want to look at is just like, how would we actually go about getting that grid effect, right? Because right now we have these triangles, and maybe you want that, but maybe you want something that's more gridded, and more in that kind of vein. So I think what I'm going to do is come back up here to these polys, right? These are my original gridded polygons, and you can see that we're definitely getting some, we're definitely getting some sticky stuff in the viewport there. So what I'm going to do is now make some kind of rendered geometry from this. So I think what I'm going to do is, no problem, man. Yeah, Vic, I'm glad to be able to help you figure it out a little bit. So the last bit, I think, is just figuring out how to make this in some sort of gridded, geometry fashion. So I think what I'm going to do is just make another for each that's going to create our kind of render geometry here, right? So we're going to put this in here. This will be our render geometry, right? So this is going to loop over everything. And if you're new to Houdini, anytime you see these little for each, basically what that's doing is it's taking all this geometry and you give it some sort of piece value. Here we're saying primitives. So it's going to repeat that for every single piece in this. So it's looping over this 128 times for each of these primitives and then spitting something out. So I can say just one single pass and I can select, single primitives from this loop. And you can see how, we're not doing anything, but it can work pretty quickly depending on what it is you're doing. So maybe what we'll do is we'll add divide sop, which might seem strange because that's going to triangulate it, but we're going to undo convex polygons. Maybe do bricker. Maybe we'll just make these. Just trying to think here. Is there a way to do this? Oh, shoot. I've had that happen before. I mean, that's a gridded pattern, but I don't love that these little edges are kind of still there. I'd like it cleaner than that. Just trying to think. Because we don't have like a regular grid to start with. So I'm just trying to think of a good way to do this. I guess you could, if you wanted something that's like, oh, wait a second. Could we use lot subdivision in a completely get somewhere here? I mean, we could just subdivide it, but quad remesh beta. No, I don't think that's, I mean, yeah, it would certainly work, but I'm not sure that would do exactly what we're wanting here. Yeah, it's sort of working. We could just do a subdivide. See how that'll work. Yeah, see, the problem there is it depends on how small it is, right? So actually, I'm just going to undo that. It seemed like that subdivision was actually getting us a nicer result. But truly the best one is going to be the divide. So let's do this. Let's do a divide. That'll work. Oh, I think I know what we could do here. Well, let's bricker these polygons. And what we're going to do is do a little expression here, I think. We'll add a null. We'll just say, just to make it a little easier to understand what's going on here, we'll say in geo. And let's change this divide. So this is just like kind of, again, like a grid division, right? So we can reduce the size of this until we start to see it actually divide here. Oh, it's not, we're not seeing it because I had not visualized on it. So I'm just gonna maybe reduce this a little more. Maybe like that. That could be a good amount. Yeah, that looks pretty good. So that's like a much more regular kind of thing. I mean, we could change this. Just middle clicking on that if you can't see what I'm doing there. Maybe 0.4. That's good. So the really crazy thing when you think about what just happened there is as I'm changing that value, it's literally looping over 128 different primitives, creating 65,000 primitives, 71,000 points, and just doing that so quickly like that. It's crazy. And if you were to do a compile block on that, it would get even faster. But we talked about that before. So what I'm going to do just to maybe make this a little cleaner is I'm going to have it offset that bricker pattern, the grid pattern, based on the center point here. So what I could do is I can take this incoming geo. Now I'm going to hide this because these points don't actually exist in there. It only knows about this geometry coming in. This is all it knows about. But it does have a centroid here, a center. So what we can do is we can say offset can be centroid. And this will come up where you're going to say what surface node, and we can just make a little thing here where we go up, up. So 2 dots means go up a level. So like from this, go up into our network and look at the nodes around it. We can say in geo, and then that's fine. And then now we're going to say, what do we want to look up? And we can see here the type, which is this part right here, should be one of dx, dy, or dz. So we want to see the offset in x, then y, then z, obviously in that order. So we're going to get the centroid in x. We're going to say d underscore x, close that parentheses, and that's going to give us our offset. So what I can do then is just take this, tab, paste, say y, enter. Oh, well, I could have just probably tabbed and paste again, but that's okay. I'll paste one more time, say z, z. And now this will be, should be centered a bit more on each of these individual pieces. So hopefully that'll be right. Let's see, 3. And that should match, negative 3.70, 0.5. Cool. And if we change this, we might, let's see here. Yes, this is H script. Yes, sorry. If you want to find those functions, like a list of them, you can go into the, you can search expression functions in the help document here. If you just say expression functions, there we go. And then this will give you a list of all of them. It'll take you to that. And then this is all of them. And so you could look here and you could, I mean, centroid is there, right? But you can see all the different ones here, fits and different things like that. And those kind of nest together. So you just nest them if you want to do like, if you want to fit a range of a certain thing, you just do it like that. And some things are similar, like point and primitive and things like that are very similar to how they work in Vex. So, but it's H script. Yeah. I mean, the real way to do that too nowadays is probably using Python, but I'm not a Python person. So I'm just going to stick with what I know, and that's fine. Well, anyways, this will be fine. This will get the point across. We don't have to do any, I'm not going to go nuts on this, but let's set this back to 0.4. There we go. Just a little less geometry in case your computer doesn't like having a ton of geometry. And so now we have this more regular grid pattern, and we should be able to use this to modify this. So let's do a point deform. And what this is going to do is need 3 different things. The mesh that we're going to deform, which is this one. The rest points, which is going to be this. And then our deformed points, which is going to be our simulation. So one thing we want to take from this is what's our piece attribute. So I think we should have a piece attribute here, which is going to be index. So that's good. Let's just double check that that's looking for a... Nope, that's looking for a point attribute. So I do need to throw this over here as well. So I'm just going to shake that off. And we should still have the index there. So I'm just going to promote that to the points. So this is going to make an index point attribute as well, because we need an index point attribute here and an index point attribute over here as well. So we have an index and index. So that's just going to match them all together. We can see it's already starting to work. So our piece attribute, we're going to say index. So that's going to clean this up even further. The reason that you were seeing that, hey, SB, thanks. Thank you very much. Thanks for joining. So the reason that it did work before we did this is because it was able to kind of calculate it based on the points around it. But what you'll see here is that we're going to have some interaction with kind of the neighboring points here. You're going to see kind of this softness here because these points are being seen by both of these sections. So when we say give it the piece attribute of index, yeah, not too late. That's okay. When we give it the piece attribute of index, now we're looking at each piece separately. So we're not doing that based on, based on the actual, sorry, we're actually separating this first and binding these points to it before we do any deformation. So otherwise we were looking at all the points across all the separate pieces. So the only thing that we need to do here is kind of play around with some of these parameters so that these become a little cleaner, because you can see that there's definitely some weirdness going on here. And if we look at this, it's because really we don't have probably a dense enough mesh. That's part of the issue here. And what we could do is we could kind of smooth this out a little bit more. We could give it a little bit of a larger radius to kind of collect within, some of those things will help. It kind of just depends on, it's really looks like it's a little bit of the radius. Yeah, it's definitely the radius. It's just not. All right, we'll do something like that. That looks like that's going to be a lot cleaner. So really what you'd want is for this to be a little bit finer mesh. Obviously it's pretty rough. But we can see here it's doing something. It's generally doing the job. We have a little disconnection here because the points probably aren't matching up super closely, and we're definitely getting some like random bulging and things like that. So there's some ways. I guess we could use Vellum post-process. That's a good point. Thank you. I wasn't thinking of that. It is a little calculation intensive, so I'm going to shift click all of these and then put them into the first, and we'll wire them all together. And yeah, we could do we don't want to do a Catmull Clark. We want to do a loop. No. Well, that's going to be the problem, right? Because we're subdividing. If we were subdivide this, it's going to try to subdivide the edges because these are separate pieces. I guess if you excuse me, if you like fused those points back together and turn them into one whole sheet again, you could do that, I guess. Not sure how that would work for the simulation, but I'm kind of using this as separate pieces, so that's a little bit of the trickiness there. I mean, certainly this will be a higher quality. It's going to look nicer or whatever. It's not going to be as smushed, but it is rounding those corners. And the reason... Actually, no, that doesn't work. Sorry. wasn't thinking. So the reason that that wouldn't work is because the reason that it's not working is because you would need this subdivided geometry to be the input as well, because you need to have the rest points. Well, I guess you could do it. You could do this. So this is what you could do instead. If you did want to use something similar like this, but you could actually do the Vellum post-process, what you would need to do is do a time shift here to pause this kind of at frame 1. So we'll delete that channel there. So it's just stuck on frame 1. Then you'd put this in here and this over here. And that's kind of similar. I really don't know if you're going to see a huge difference on this, honestly. Curious. Let me see here. We could do 2 different point deforms here, and I'll do that, and then take this and take this. So this is without this is low res sim deform. We'll say high res sim deform. Just deform. Deform. Just to kind of compare these. Compare and contrast. So that and that. Okay, cool. And then I'm going to shift click these and do a switch just so we can switch back and forth between them. Okay, that seems fine. Let me just see what this, if I can turn this radius down at all. Because that's going to kind of blur this a little bit more, and you really don't want to feel like blur it too much, or it's going to just kind of change how many points are being captured, right? So let's see here. How big of a difference are we looking at here? Yeah, it is different. Actually, that one's smoother in a weird way. I'm surprised. I would think there'd be, let's see. I guess it's smoother because it's subdivided. Interesting. I mean, honestly, I prefer the one that's not that way. But I mean, you know, whatever works for you. You know, that's the low res deform. This is the high res deform, and you can change those settings. I mean, there's a million different settings to change, but and then you could do something like, if you wanted to do like convert line. After this, that'll get rid of all of your, that's hard to look at. That'll get rid of all your primitives. That is difficult to look at. Well, anyways, that'll get rid of all of your primitives, and then you'll just have the lines left over, basically. But interesting. That really slows the whole thing down. So I guess you'd probably want to do that up here. Yeah, I think that's what you'd want to do, actually. But it is interesting that slows it down a lot. And I think the reason for that is because this is adding in a lot more polygons. Yeah. Because each segment is a polygon there. So, yeah, that's a little interesting. Is there a way to do that where it wouldn't happen like that? Well, I guess you could always turn this on or off if you wanted it or didn't want it, because it's obviously way faster without it. Or no, it's not way faster. Sorry. Just seemed like it was. No, it's about the same. That's why, because I had it on the second one. I see. Okay. That makes more sense. And I had it with the Vellum post-process, which takes, you know, a decent bit of processing power. Cool. Very cool. So there's something, you know, that's doing its thing. So yeah, hopefully that makes some sense and doesn't totally confuse anybody, but yeah, it just gives you a little sense of how that might look doing different processes. I'm going to turn that off just because it's a little hard to look at. All right, let's do that other example real quick. I think this one will be a little easier to deal with. So let's just do this. We'll add a geo. Let me know if you have any other questions about that. We can talk about that some more. We'll just say torus inflation. So let's do this purple. Let's go in here. Let's add in a torus. Like so. Let's just double these, 24, 48. And I'm going to do a remesh just to get this to be, I think, triangulated. It'll just look better. So let's do that. I just feel like it's going to be a better look overall for the simulation. There we go. We'll do a little smooth step there. That'll get some of that faceting out of there. Are losing a little bit of volume. Let's do like 0.75. Cool. All right, so that looks pretty good. Got a pretty nice remesh there. So what I'm thinking is we're going to do a Vellum configure balloon. And we have cloth and pressure, right? So in the past, I've talked about this pressure constraint. And it's an interesting constraint because, let's change this over to our constraint geometry. We have our cloth here. You can see Vellum cloth 1. And then the very last one's going to be a pressure constraint because it's one constraint for the whole thing, right? So that obviously causes some issues there when you're dealing, if you want sections of it to inflate, because it all has the same it all has the same constraint that's driving it. Sorry, I'm just going to adjust something real quick while I'm, give me 1 second. Just been dealing with I have like a little cushion that is nice and supportive, but wasn't sitting in the right spot. So it's just driving me crazy. Anyways, so I think what we can do here is let's go into our help system and let's go to Vellum. I'm just going to slide this over to this side maybe. And I'm pretty sure if we look here, Vellum attributes. So if we come down here, these are all the different attributes we can tweak. And I'm pretty sure that there's one that's going to be, yep, right here. Pressure scale. So I think this is what we're going to want to do. So we can add this pressure scale constraint per point and animate it. So I think that will be exactly what we want to do. So this float attribute will be seen by Vellum and it'll know what to do with it, basically. So that's great. So let's do a Vellum solver. Needs a 2-minute break. So there we go. All right, so we've got this going. Let's actually take this and just do a match size with it. And that will allow us to put this at the minimum, which is going to be the origin basically. So we're changing the Y, to minimum. So it's sitting on this kind of imaginary ground plane. And then when we add our Vellum solver in, give it a ground position, that ground position will be right there. So that's great. We've got our pressure and our cloth. That's really all you need for a balloon in Vellum. And let's just hit play, and we should see that this thing will turn into some sort of a balloon of some sort, and it'll get real smushy and weird. In fact, we'll probably just up the substeps a little there, just to help it sort of do its thing a little better. And maybe we'll do a little more constraint iterations as well. Cool. All right, let me just see what this cloth is set to. Maybe we'll give it a little more stiffness here. Let's just see what that does for us. Yeah, I like that better. I want it a little stiffer. Maybe give it a little more pressure. So if we up the stiffness of this pressure constraint, I think that will give us more pressure. I'm pretty sure. Let's see. Yep. Cool. All right, that looks like that's doing something pretty good. I think if we do the rest length scale as well, if we did this like 1.1 or something, that's going to give us a little bit more of like an overinflated kind of look where things get a bit more puffy. Because I think if we go all the way up with this, it's not going to like be solid. You know what I mean? It's going to be stiffer. It's going to have like a bit more volume, but it's not going to be totally like inflated. So I think if we do something like this, we can get a more solid inflation look, right? So it's kind of a mix of a few different properties and attributes and things like that. So, kind of keep that in mind as we're sort of playing around with this a little bit. I'm going to turn the stiffness down a little bit. Actually, let's just go back here. What did I have that at before? Let's do this at 1,000. We'll put this at 1.25. Just don't want it to be too stiff. There we go. Cool. All right, so let's do a let's add a pressure or let's add some attributes up here to this geometry. So let's make a null just over to the side. This is where we're going to get it from. So we'll say maybe like PT pressure, something like that. And let's do an attribute adjust float. Again, just nice to have a simple interface to be able to use for this. And let's go and grab that name. So it's going to be pressure scale. It's going to be a float attribute, which means it's got a decimal. These are all float attributes here. Anytime you see a decimal in Houdini, you're dealing with a float. So we're going to do pressure scale. And let's visualize that. Make sure we have the visualizer turned on here. Yep, we do. And let's turn this on to be a noise. Oh, would help if I visualized it or would put my visualizer there. Okay, so now we see that we have some geometry that's showing up, or some attributes that are being visualized here. And we're basically dealing with the exact same geometry as here. In fact, we could just bring it from this match size instead. That's probably best, just to have it in the exact same spot. Just easier to visually see what's happening. And let's just give us some areas where we're going to have no inflation like that. And then maybe somewhere we're going to have a lot more inflation. So we're just kind of reducing the scale of that. And let's turn on the animation of the noise. And I think that's too fast. So let's do the pulse duration to be like 5 maybe. No, it's too slow. We'll just play around with this a little bit. Oops. I'm just going to kind of tweak some of these properties. We'll see sort of how this works. No, I wasn't really planning on doing any rendering. That's always not my not my strong suit. So a lot of times it's just better to kind of stick with what is will work better. Let's see if we can play around with some different noise types here. Just going to tweak some little settings here just to see. Yeah, rendering and streaming is definitely a pain too. That's a great point. I hope to fix that at some point later this year because I'm going to split my streaming into its own separate computer, but I have to buy a computer for that. So that's hopefully for later this year. But just waiting for some funds to do that. So that should happen. Anyways, yeah, that looks kind of cool. It's kind of an interesting look. We'll see how that goes. I don't know. I'm not sure. I haven't really played with this before. But we have our point pressures now, right? So if we come into here, we should be able to... I just want to look here too, because there is a... I don't think that this is a part of the Vellum constraints. No, I don't think we can do that. And there is another one. What is it? Vellum constraint properties. But I don't think that there's a pressure scale in here. No. All right. So what I'm going to do is, well, let's just do a pop. Let's just do that. And we should be able to... I've never done this before, so I'm hoping that this will work right. So let's just bind. So we're going to bind... actually, no, we're not going to bind because we need to set this up just like we were doing before. So we're going to say input 1, stop. We're going to find that path that we had created before, which was... This is our grid inflation. Point pressure. There we go. Have that input 2, and we'll just say, so for this we do get, do a get attribute. What we can do is we can say second input. Signature of this is going to be a float. Yes. And the attribute name is the one I had from before, which is pressure scale. And this is the exact same geometry. We know it's identical. So we're just going to use the point number. So we can here use point number and put this into this first one here. And you can see that that grays that out, pointer primitive. And now this data coming out should be that data from that second input. So what we could then do is say bind export, which is basically going to write that to this geometry. And the reason that doing this in here is different than doing this in the upstream is that this is actually going to be running within the dynamics simulation. So when we jumped in there, we're now in our dynamics simulation. We can work in here. So we're going to do the same thing here. We're going to do the same name. We're going to call this, we're going to call this pressure scale. It's going to be a float. That should be good. If we go to our Vellum object with our geometry, we should be able to look here and see pressure and then star. We should see we have a pressure scale in here. Let's see if we have any values written in there. No, I don't think so because we haven't run a frame of this yet. We go to frame 1. We have a pressure scale there, and that looks right. So we have pressure scale showing up. So that's good. So we've got some attributes there coming in. All right, so let's jump back up here and see what our solver does. So this I'll just color, color yellow. And you know what we probably should do now that I'm thinking of this? We should probably have the minimum value be like, good night. Yeah, thanks for joining. Nice having you. So let's do the minimum value as 0.5 and the maximum value as like, I don't know, 3 maybe? I don't know. Let's see. Or we could do the minimum value as 1 so it doesn't like deflate. So the thing I'm trying to think about here is that we want to have some soft position like constraints. So let's do that. So let's do some soft pin. Oh, yeah, for sure. How we see the reference connected lines. Yeah, it's under view and it's under dependency links, and you can say show for selected nodes. You can also say show for all nodes, and that'll show all of them. Yeah, Carlos, I think everybody is. It's time. I mean, I think the first version will basically just be a one-to-one redo, but it'll just be a more stable viewport is the hope. And then over time we'll see more new features added. But Vulkan is a big language. It seems like it takes a lot of code to do what you want it to do. At least from what I've seen, it seems pretty intense. Anyways, but yeah, these are the dependency links. You can hide them. You can show for selected nodes, or you can show for all nodes. There's probably a hotkey for that. I can't think of what it is off the top of my head, but yeah. So there you can see all the different dependencies that are being created and things like that. So these are probably created by references that are inside of these that look to the incoming geometry. So that's most likely what's going on there. But yeah, if you do for selected nodes and you select just this node, you'll see, yep, there's a connection right there. Yeah, no problem. No problem. I think that actually used to be on, like I used to see that way more often, and I think we've made it so that that's not the norm anymore. But okay, so for the cloth, what if we do a soft pin type for all of them? Just do it like that. Oh, actually, no, I'm not going to do this because that's not going to, doesn't really matter there. But what I'm going to do is add some vellum constraints. So let's just softly pin it in place, like a really, really light pin in place. So let's say pin to target. We're going to say soft, same as position. There's no animation, so that's fine. And let's give it like, I don't know, let's give it like a little bit of softness so that it can move around and do stuff, but isn't like kind of wandering on us here. And I think we can even make that lower because I think I might have that too high. So let's do like, just like even 1 probably is enough just to give it some constraints. Yeah, maybe close. Let's do 10. Yeah, so we're giving it a little bit of something to kind of lock it in place, but we're allowing it to sort of move around a little. Let's see here. What if we change the stiffness of that? I wonder if that'll... I'm just going to change a couple little things here, like give it a little more rest length scale. See what that does for us. I think that might just make the inflation effect a little bit more extreme. And maybe what I'll do instead too is we can make the noise of this oh, right. It's just not visualizing it because we need to give it maybe an auto, something like that. There we go. And maybe if we make the element size a little smaller, that'll be more interesting. Yeah, maybe something like that'll be a little more interesting. I don't know. Let's see. Again, like I said, I don't really know what I'm expecting here, but let's just go kind of crazy here, see what happens. Yeah, it's kind of cool. Pretty funky. Different than what Ben did. Let's see. Maybe we'll just pin these a little harder. Oops. I went all the way to the end. That's not what I want. Pretty funky and weird. I don't know what's going on. Yeah, that's funny. Yeah, I could see that. Oh, it's so weird. No mops set today. No mops today. You know what? I think we've got a couple things happening here. Looks like we need to maybe damp out some of this. Maybe doing that will help. Okay. Yes, that's definitely it. Let's just see if we can get a better... just adding a little bit of damping in here just to kind of help it not kind of get too crazy, you know? So it doesn't kind of like run away on us and get real bouncy and goofy. This is a weird effect. I don't really know what it's totally doing, but it's cool that you can kind of control this pressure per point. Probably would make more sense to do it with like, instead of just random noise, but maybe do it like based off of point positions or something, you know, like something like that more so than just random noise on this weird object. Like, it's definitely really strange. Just gonna add a little more damping in just so we don't have any super strange stuff going on. Oh, Frankie, no, we didn't do any mops today. That's going to be on Friday. We changed it around to be a mops Friday instead of mops Monday because I wasn't feeling good. So we're going to do Friday instead. All right. Well, I think that this will be kind of enough to sort of see what's going on here with some pressure type things. The other way you could obviously go about doing some of this stuff would be using like, yeah, well, I mean, the muscles in Houdini are now done with Vellum. I think something really weird happens there and it doesn't know how to like resolve that situation right there. Maybe I'm just putting the things too high. But yes, muscles are done with Vellum kind of now. So it does make sense that it looks almost like muscles. The last thing I'm going to do here is just maybe make these pins a little stronger and see if that helps us. Let me just do this 1 and 100. Yeah, that's actually kind of doing something interesting. It seems like it's morphing around a little less. Oh yeah, that's working way better. So we just want a little bit of a stronger pin to keep those points in place. Yeah, that's kind of cool. Super funky. So when I'm doing these constraints here with the points, just to clarify what I'm doing there is I'm actually pinning all of the points softly, like in their world position, right? So I'm giving them kind of like springs to their world position, so they're not able to just kind of fly away wherever they want to be. And so that's helping it sort of stay in this general shape. And then from there we can kind of do different stuff with it. And you know, you could play around with these different values and things like that. I'm not sure, you know, maybe this being lower would be better. No, probably that's too low. You know, you could play around with the values here of the pressure scales and stuff. So, you know, maybe that's more what you want. You could do the noise. These pressure scale values could come from anywhere, right? They don't have to come from what we're doing right there. So you could do them from any number of different places. But hopefully that's kind of an interesting little look into how this might work and how Let's set this back to 10 so it's a little more visual what's going on there. But yeah, hopefully that's kind of an interesting look at. I wonder what it's doing at the bottom. There we go. Yeah, it's really flat. Cool. You could do this in 0G as well, which might be an interesting thing to do if you took the ground position off and took gravity off. Yeah, Tommy instead of the torus. Well, play around with it. See what happens. You could always just remesh Tommy and see what happens, Might look like he's got some sort of weird, thing going on. I don't know. So this is like a zero gravity simulation of it, basically, which really isn't going to do a whole lot different. It's just we've turned gravity off. There's no ground plane, that type of thing. So it's kind of a different look as well. Honestly, I kind of like it with the gravity and all that stuff, but feels just a little more fun that way. Anyways, I think we're going to start wrapping it up there unless anybody has any further questions or clarifying type things. It's pretty fun. I was hopefully this was an interesting example for everybody, and yeah, it certainly is a neat little process to kind of look into. For sure this kind of grid situation here I think turned out pretty close to what we had in the example. Like it's pretty close. Like it's not exact, but certainly is interesting. Doing something fun, and kind of did our own little take on it. A little bit of different shapes and different things like that. Gave it some noise versus just having it go up and down. Just a few little things like that to make it a little bit different, a little unique. So yeah, I think that's where. Oh, cool. Very nice. First time doing a live. Well, great. I mean, I think the idea always is that we, it's just me, but I always want this to be sort of a, conversational type thing. So that's why I love having everybody here chatting and talking about how they might do something or different ideas and things like that. I think it makes it really, just makes it a lot more fun. Yeah, Vic, I'm glad you could, be a part of it, and just, yeah, sorry it took me so long to get to your suggestion. It was a good one. I kept looking at it and thinking, oh, didn't I just do something? Anyways, I just never got around to it. So glad to do that. So thanks everybody for joining. Thanks for being a part of it. If you guys want to be a part of the community kind of after the stream, away from the stream, you can check out Houdini Hangout for, a Discord invite. You can join the Discord server there. And there's a lot of great people that kind of jump into the help section and things like that. If you ever run into any problems with doing something from one of the streams, I'm happy to help you over there as well. Try to figure something out. But I think that's where we'll end it for the evening. And thanks for everybody for chatting and being here to kind of make the stream more interesting than just me talking to myself. And like I said, we'll be doing a stream on Friday. That's at least the plan. And we'll do some MOPS related things. So some different kind of motion graphics-y stuff. So that should be fun. And if you need any information or anything, I joined the Discord while Houdini crashed. Perfect. Well, glad to have you in the Discord server. Lots of really smart folks over there. Henry, who'd made MOPS, is in there from time to time giving people advice. I know he was helping Zach out with some things and all sorts of different stuff. So it's just really cool to see people getting helped, when they need it. I mean, there's tons of different places to do that. It's not the only place you can get it, but I just like to offer it for if anybody wants my help. So not that I know anything special, but I like to figure this stuff out. So it's pretty fun. Anyways, cool. Well, everybody, thank you so much for joining, and we will see you on Friday. And if you need anything else, you can hit us up on the Discord and ask whatever questions you might need answering. But have a great night, everybody. Thanks for joining, and I'll see you next time. Bye, everybody.